Hello everyone, my name is Engineer Vandana Sharma and I'm going to present topic of embedded systems. We'll learn what is embedded system and how do we program it using C language, using embedded C. So let's start. When we talk about embedded systems, embedded means something which is embedded, like two things. So embedded means two things together. Combination of two means combination of software and hardware. And when we see things around us, there are many several devices which are being operated on software. So they have a hardware and the hardware runs on software. So whether it's a computer or laptop or mobile or any other gadget, they all are working on some softwares. But do you really think that every device is kept under the category of embedded system? Let's see. Let's explore the answer for this particular question. So let's talk about the feature of general purpose computers. Computers, yes, they have hardware and they they operate on some software, some operating systems. So here are some attributes of general purpose computers. For example, laptops, workstations, servers, smartphones, tablets. They all are able to run on a variety of software. They contain relatively high performance hardware components, fast processors, data and program storage. They require an operating system. These are designed for heavy user interaction, uses a variety of peripherals like displays, keyboards, mice, internet connections, wireless communication capability. These are very expensive. The range varies from $100 to $1,000. They use a group of integrated circuits or chips, ICs. One implements the central processing unit, several implements data, memory and program storage. So various ICs, various functions. So the entire hardware becomes bulky because it serves many purpose, not only specific purpose but many purpose. We can perform actually many tasks on computers. This is an example. Now let's talk about embedded computers. Embedded computers, they are intended to perform a specific task. So when we talk about microcontrollers, yes, they are intended to perform specific tasks. General purpose computers, they have microprocessors. And when we talk about microcontrollers, these are used to perform specific tasks, and embedded computers are kind of those. The resources can be implemented on a single IC, single integrated chip. They include a variety of peripherals, timers, analog to digital converters, digital to analog converters, serial interfaces. Small size makes them very versatile. So robotics, gaming, digital cameras, communications, automation, office equipment, aerospace, home appliances, music players, TVs and entertainments. All these are examples of embedded computers. These contains firmware, only the needed software which is not intended to be changed frequently. May contain real-time operating systems, RTOs, which are used as a task scheduler. They are having very low cost because the cost varies from tens of cents to a few dollars, so very cheap. Now let's compare the attributes of general purpose computer and embedded computers. Embedded computers, these are embedded in the system, they control enough performance to get the job done, implemented on a single chip, software not intended to be changed by user, low cost, pennies to dollars, it varies. And general purpose computer attributes, they have embedded hardware resources to support running many types of software, sufficient performance to run many types of software, sophisticated operating systems to manage resources, OS like Windows, iOS and Linux, usually implemented across many chips, CPUs versus RAM versus hard drive. They are of higher cost. The cost ranges from $100 to $1,000. However, when we talk about general purpose computers and embedded computers, we often by mistake consider smartphones and tablets as embedded system because originally they were considered to be embedded system, but in the past decades they have become so sophisticated that they have become general purpose. Many tasks can be performed using the smartphones and tablets. So we keep them in the category of general purpose computers. Now let's talk about the programming language we use. We use C language. Why only C? So here are some key features of C we are utilizing to do programming for microcontrollers or for embedded systems. C allows the programming low-level access to the machine architecture. Compiled C programs are memory efficient and can execute very fast. Higher level language constructs allow designs to be more complicated, reduce the number of bugs, and help get more done per unit of time. There are some data types as well, like any other programming language. C has data types like characters, integers, long. So unsigned character, signed character, unsigned integer, signed long, unsigned long. They varies in size also. So when we talk about size, we talk in terms of bits. So unsigned characters, they are of 8 bits. Similarly, signed characters are also of 8 bits. Unsigned and signed integers, they are of 16 bits. Unsigned long and signed long, they are of 32 bits. Range also varies, dynamic range for character, unsigned character, it is from 0 to 255. It means it can store values, 256 values total, from 0 to 255. Signed characters have the range from -128 to 127. Unsigned integers have the range from 0 to 65,535. Signed integers, they have the dynamic range which varies from -32,678 to 32,677. Unsigned long, they have the range from 0 to 4 million to 94 crores 99,67,295. So these are the values and the range, dynamic range for specific unsigned and signed longs. Let's talk about the number representations. How do we represent numbers? We represent numbers in decimal, hexadecimal or octal format in C. So decimal representation is generally like this: 0, 2, 63, 83. Octal is like 0, 0, 0, 2, 0, 7, 7, because it's combination of decimal and 0 bit. So 0, 0 octal formation. Okay. Then we have hexadecimal. In hexadecimal, we have the format like 0x0. So it's a combination of alphabet and numerals. So let's talk about the bit manipulation, because we mainly work on bit. So how do we shift? Left shift or right shift? So when we want to do some left shift or right shift in the registers and the operand values, we use less than or greater than sign. So these are the logical operators. And let's say you want to shift the data of this hexadecimal data you want to shift. So to 3 bits you want to shift. So it will produce result like this. Then AND operator, basically it does multiplication. So it will work on 2 operands. It will do the operation of AND on 2 operands and produce the result. Similarly, we have OR operator. The sign of OR operator is like this, and it actually ORs the 2 operands together and produces the result. We have XORs, wherein the sign of XOR is like this. It will XOR the 2 operands and produces the result. Then we will talk about the scope. So how do we generally declare variable? So globally, locally or static. So if it is defined or declared globally, the variable is defined or declared globally, then it means it can be called by any function anytime. Okay. If it is defined locally, only by a particular function in the particular execution block or declaration block or the set of instructions, it can be called. Then we have static. Static means the variable will retain its value across function calls, and there are situations where this is very useful for retaining state in a subroutine function when you call subroutines or functions. So it will retain that same particular value, it will not change anything or do any modifications. Then let's talk about the infinite program loop. So whenever we want something to be happened or executed repeatedly, we are going to use forever loop. So forever loop, it will keep on repeating some set of instructions, some sort of operations. It will keep on happening. Let's say you want to move, you want to turn left or right or do any operation you want to increment. So that particular operation will be implemented in forever loop multiple times, okay, till the duration of time you want. So now when we have discussed all these things, let's talk about the program. So we'll see for loops usage also, the syntax also. So let's quickly discuss one short program in which LED blinking is there. LED blinking using 8051 microcontroller. So LED is basically light emitting diode. We interface microcontroller with the LEDs, and it is basically used for indicator. So in many electronic devices, it is used for indication purpose. LEDs are also used in designing of message display boards and traffic control signals lights. It comes in various colors: red, green, blue, yellow. And here is a prototype. On Proteus software, we can actually replicate the circuit. So we can design our prototype here in Proteus software, and we can see that in for example, we have used Atmega's 882C51 microcontroller. It gives us 4 ports to be used. It has address and data lines also, 15 address lines and around 8 data lines. We have 0 to 7, and we can see that LEDs are connected here on port number 0, and with every LED we will be connecting one resistor to limit the current, rush of current. And then we have some parallel arrangements for crystal oscillators also, capacitors and crystal oscillator, and some different arrangements for ground, and we have to connect one resistor also. So this is the entire circuit. Now this is the circuit arrangement in which we have connected our D1, D2, D3, D4 to various lines. So here P0 1, it starts from P0 1. So let's see the programming. As soon as we start writing the program, we call the library which is already inbuilt, register 51.h, for writing the program, embedded C program. We call void main, then curly bracket starts, unsigned integer k, unsigned character L, B, while L, we are defining here integer k and then character L and B. While L, then curly bracket starts, P0, port number 0, P0, that this particular pin P0 is equal to, it has value 0x01, it has one signal. B is equals to P0, for loop will be start 1 minus 0, termination with semicolon, then 1 less than 3000, values 1 or L plus plus. So L plus plus, so L minus 0, L less than 3000, L plus plus. For loop starts k is equals to 0, again because you are declaring integer also, integer data type also. So when you are going to send the signal 0101 format, so how this is going to be changed bitwise. So k is equals to 0, k less than 8, k plus plus. These are the two variables you are defining outside. Then again curly bracket starts, b is equals to b less than 1 for shifting the contents towards the left side. You can see the bulb will glow one by one, and the data, this one value of 1 is getting shifted on left side. P0 is equals to b, and the curly bracket stops, and the output will be like this. 1 will be here at this particular instance, then at this point, then third, and so on. So fluctuations, one by one the LED will glow, and it will be repeated till these many times up to this time. So this is the entire program or embedded C language. That's all from my side. Thank you so much.